Have you ever wondered why GPS needs data from at least 4 satellites to find your exact location? Well, it all comes down to precision. With just 3 satellites, we can narrow it down to 2 possible locations, but to be absolutely sure, we need a 4th satellite to eliminate any errors, especially those caused by your device's clock not being perfectly in sync. In short, the 4th satellite helps correct timing issues, making sure the location you see is spot on. Let's break this down further. Before going on, let's answer some important questions. What is GPS? How can we determine our location with this system? What is the necessity of obtaining data from a minimum of 4 satellites to determine our location? What is the reason for the additional improvement in accuracy when data is obtained from more than 4 satellites? Additionally, what is the significance of relativistic time dilation in this context? We should commence immediately. I am obligated to retain the explanation as straightforward as feasible. What is GPS? Global Positioning System GPS has a collection of presently 31 satellites orbiting at an altitude of 20,200 kilometers above the Earth's surface. The orbits are configured in a manner that a minimum of 6 satellites are consistently within visual range from any location on the Earth's surface. These spacecraft are initiated and overseen by the Department of Defense of the United States. However, the information obtained from these satellites is available for use without restriction by any individual located anywhere on Earth by certain regulations. Additionally, what is the nature of that information? Each satellite transmits data in a continuous manner, which comprises its precise location and the time at which the satellite transmits this data. The satellite services conclude at this point. The remaining tasks are completed by the tiny GPS-enabled device in your possession. On your device, hardware for the acquisition of satellite data and software for decoding and processing will be present. Locating a location via GPS. Assuming that I am situated at this location, which I am unaware of, and I activate the GPS feature on my device, my electronic device commences receiving data from satellites that are visible. We could say that this satellite transmitted data to me. This information encompasses the satellite's location and the time at which the data was transmitted. This information is actually in the form of electromagnetic waves which travel at a speed of 3 lakh kilometers per second. Therefore, I am aware of the time at which it was transmitted and the velocity at which it moved. Right now, I examine the time on my timepiece upon receipt of the data and contrast this with the time at which the data was transmitted. Additionally, I can effortlessly determine the duration it took for the data to travel and contact me via the satellite. We could say that it required 0.08 seconds to obtain data from the satellite. I am aware that in a single instant, it covers a distance of 3 lakh kilometers. Therefore, I can ascertain that in a mere 0.08 seconds, it would have traversed 24,000 kilometers. In other words, I now understand that I am situated at a distance of 24,000 kilometers from this specific satellite. However, I remain unaware of my precise location. Using additional satellites. If I construct a sphere with this satellite as its center and a radius of 24,000 kilometers, I can assert that I am currently positioned on the sphere's surface. I am currently in search of an additional satellite. Additionally, I discover that I am situated at a distance of 23,000 kilometers from this second satellite. I also construct another sphere in the same manner. Now, according to the data from the second satellite, I am lying on the surface of that sphere. I search for a 3rd satellite and I construct the 3rd sphere. Thus, I should be included within that domain as well. Therefore, there are 3 spheres and I am situated on the surface of each one. This implies that I am directly at the point where these 3 spheres intersect. That is to say, I should either be situated on the red dot or the blue dot where the spheres intersect. Given the blue dot's location in deep space, which is inconceivable, I can verify that my position is the red dot and indeed, my location is identified. Why data from 4 satellites is necessary? In this procedure, we place excessive reliance on the synchronization of the clocks of the 3 satellites in our device. We assume that they were in perfect harmony. Why is it necessary to collect data from a minimum of 4 satellites? In actuality, if we examine 3 or 4 distinct timepieces, we would observe minor discrepancies in the individual times. In this instance, we were focusing on a travel time of 0.08 seconds. An error of even 0.01 seconds will result in a 30 kilometers discrepancy in distance. Fortunately, each satellite is equipped with atomic clocks that are both precise and costly, synchronized to nanoseconds. Our concern, therefore, should solely be about the clock of our device. It is not practicable to incorporate expensive atomic timers into our device. Right now, what is the solution? We acknowledge that we are utilizing an inaccurate timepiece, which deviates from the time of atomic clocks and the satellites. To compensate for this, I can account for the time drift and achieve satisfactory results. Let us assume that my device's clock is operating prematurely by 0.01 seconds, which I am unaware of. Right now, I may determine all distances as being lesser by 3,000 kilometers, which I am also unaware of. At this point, I choose to investigate a fourth satellite and create a fourth sphere in the same manner, utilizing the data from the fourth satellite. Presently, we possess 4 orbs. In an ideal scenario, in the event of zero drift, a common intersection should be achieved by these 4, and that would be my location. However, at present, due to the synchronization issue with my timepiece, I receive a variety of positions when any 3 of these satellites are employed in conjunction. The distance between these locations is a sign of error in my device's time. Now I can adjust my clock or alter the sphere diameters so that all 4 spheres intersect at a singular location. Indeed, that is my location. The time adjustment that I have undertaken to acquire this compensates for my time drift. Thus, we succeeded in overcoming the shortcomings of possessing an inaccurate chronometer by employing data from the 4th satellite. This is why data from a minimum of 4 satellites is required to determine the location. However, in specific circumstances, 3 satellites would suffice. For instance, if I am already aware that I am on Earth's surface, Earth acts as a single spheroid, and by using the other 3 satellite spheres, I can locate myself. Typically, GPS has an accuracy of approximately 8 meters. Nevertheless, there are still a few inaccuracies: speed variation, refraction of electromagnetic waves as they traverse various strata of the atmosphere, and multipath signals, among other things. These inaccuracies can be further reduced by utilizing data from the 5th and 6th satellites. Increasing the number of satellites will enhance precision. Time dilation and relativity. There are additional matters requiring attention, such as the effects of time dilation. According to the theory of relativity, the passage of time differs between 2 objects if they have relative velocity or are subjected to varying degrees of gravity. Both conditions apply to all satellites. Compared to the receiver, the satellites are moving at an extremely rapid pace, resulting in relative speed. Additionally, the gravitational force on a satellite is lower than that of the receiver because gravity decreases as altitude increases. As a result, there is a disparity in gravitational force. Increased velocity reduces the speed of the satellite timepiece by 7 microseconds per day, while a decrease in gravitation accelerates it by 45 microseconds per day. The overall result is that by 38 microseconds per day, the satellite clocks operate faster. If not accounted for, this will result in an 11.5 kilometer error in position each day. No internet required. Additionally, an intriguing aspect is that to receive data from satellites and determine our location, an internet connection is unnecessary, nor is mobile network coverage required. However, internet connection or mobile network coverage will undoubtedly be beneficial to inform you of what is present at your location. This can also be accomplished using pre-installed data. The United States owns GPS, but other nations maintain comparable systems. That concludes today's proceedings. I appreciate your attention. Enjoyed the video? Don't forget to like, subscribe, and leave a comment below. Your support means a lot and helps us bring you more great content. Thanks for watching.